as you will see from the conclusions of this paper, I'm being sincere in trying to make this presentation as non-transparent as possible, so we have dish noises and confusion about the software and so forth. Our standard thought about transparency is that it must be a good thing. But I'm going to argue today that, in fact, there are situations, important situations, in which the transparency of the underlying production process in a society can actually make it easier for an authoritarian government to function. And the lack of transparency is one of the foundations of governments being willing to cede power to their own citizens. So there are some interesting examples of this. One of the things we note is that there are differences in supervising problems for perennial and annual crops. Annual crops are very easy to supervise in an authoritarian setting. You have somebody with a whip driving everybody else and treating them like slaves, and they can still get pretty efficient harvesting with annual crops. With perennial crops, that doesn't work so well. And Fleck and Hansen have an interesting history of ancient Greece in which they point out that whilst Athens and Argos were relatively free societies, they cultivated olive trees, it was easy to harvest. They were able to delegate the harvesting to their own citizens, and people had an interest in harvesting the crop. When they became occupied, the occupying power could no longer make olive cultivation work properly, and they had to revert to other kinds of cultivation. We also find that there are empirical relations in the literature. Holbein and Comyn find that democracies are faster at adopting what they call successor technologies. So they typify various industries and show that as you replace sailing ships with steamships with diesel ships, that it's the democracies that are innovating faster across a wide variety of processes. So there are a variety of reasons why we might think of connections between the underlying technology and the regime type. But I'm going to argue here by constructing a game and then presenting some evidence that will maybe persuade you that there's something to it, that in fact what's going on is that if the production process is opaque, the government can't tell whether you're actually hard at work or whether in fact you're feigning to be productive while you're preparing a rebellion against the government. So in this game that I'll formulate, time can be either spent preparing a rebellion or producing, and there are variations in productivity that the government isn't able to observe. So if the government opts for a difficult to monitor technology, it has the potential of doing really well. It has the potential of gaining from access to the productive technology. But at the same time, this comes at the cost of added risk that the government might be overthrown. This is a phenomenon that Kedzie referred to as the dictator's dilemma. Dictators and authoritarian regimes more generally want to take advantage of all the aspects of modern technology, but they fear that if they do, that technology might be turned against them or be used as a mask for other activities that go against the government. And so we see many cases of governments paying fairly significant costs to avoid using more modern technology. During the days of the former Soviet Union, the government did not distribute phone books. Well, that's fairly basic, and it has huge efficiency costs not to have phone books, but of course it also made it harder for citizens to coordinate rebellion. So these strategies come at various costs. So in the analysis that we'll see, an authoritarian government has various options. One of them, that was used right here in Spain, was for the authoritarian government to simply transit to democracy. It might be that choosing amongst various options, either using a primitive technology, using an innovative technology and maybe being overthrown, or turning things over to a democracy and using an innovative technology, the government might simply prefer to relinquish control to democracy and live with a smaller share of a much larger pie. Another option, that taken in places like communist-controlled Cuba today, is for the government simply to shut down the innovative technologies and stay with safe and easy-to-monitor technologies. The advantage to the government is it's less likely to be overthrown. The cost, of course, is that they have to forego the output of the more modern technology. And finally, you have places such as the former Soviet Union during the Cold War, and today the People's Republic of China, where you have an authoritarian regime that runs the risks of adopting a modern technology and trying to maintain repression. So there are alternative theories about how democracy might relate to the nature of the economy. In particular, North and Weingast note that perhaps we see democratic transitions in order for the government to make its promises to repay debts more credible. You let the creditors sit in parliament, and then they vote to repay themselves. Asimoglu and Robinson, Tiki, and Bindini have made similar arguments about expansion of the franchise, so that, for example, people who go into military service believe the government will repay them afterwards, will make good on its promises to support them after the war is over, because they will be able to vote the government out if those promises aren't kept. Or at least they're willing to disarm at the end of the war, if the willing to disarm at the end of the war if they're given suitable promises. Roderick and Fernandez argue that there's a status quo bias. That is, there's a virus trying to make my presentation less transparent here. There's a status quo bias towards not adopting new technologies, and Comien and Hoban extend this claim to argue that that problem is more severe in authoritarian regimes. That is, in authoritarian regimes, people who want to protect existing industry have an easier time lobbying for protection. So those are some of the alternative explanations that are offered for this tendency. So in this game, we have a set of payoffs, but why don't we just take a peek right away at the game tree. So essentially, at the beginning, the government makes a choice about whether to repress and what technology to use. So there's an initial decision where the government chooses amongst three options. In one option, the government remains authoritarian, and it imposes a technology iota zero. Now, the way this technology works is that it's constant returns to scale up to capacity. So there's a capacity of theta naught, and the citizen can produce any quantity between 0 and theta naught that she wants. The more she works, the more she produces. If she devotes 100% of her time to work, she produces an output of theta naught. Time spent not working is time spent preparing a rebellion. There's no leisure time in this model. So anytime she doesn't devote to working, she devotes to preparing a rebellion. In order for the rebellion to prosper, the citizen has to devote at least a fraction, 1 minus psi of her time, to preparing the rebellion. So let's suppose that there's a task to complete, building a weapon or something like that, and either you've built it or you haven't. It's a dichotomous task. And the government can observe how much output is produced and infer from that how the citizen has allocated her time, and can tell whether or not she's prepared a rebellion. In a second technology, the government simply cedes control to democracy. So the government turns things over to the citizen. The citizen then chooses the technology, and the game proceeds. I'll talk a little bit about how that's played out. And finally, a third option is for the government to remain authoritarian, but to choose a more risky technology. A technology in which the productivity parameter is theta upper bar with probability phi, and theta lower bar with probability 1 minus phi. The government knows the probability, but obviously it doesn't get to see theta. Only the citizen sees that after it's been realized. And again, the citizen can devote time either to production or to rebellion. If she devotes time to production, the fraction of her time devoted to production is multiplied by the realized value of theta to get output. But now, note that the government has a little more trouble inferring what the citizen's time allocation was, because the government doesn't know the productivity parameter. If the productivity parameter happened to be high, and the government sees a particular output, let's say an output of theta lower bar, the capacity constraint of a low capacity citizen, the government might infer that, well, the citizen is actually a low productivity citizen working at full capacity, but perhaps instead it's really a high capacity person pooling with a low capacity person to deceive us. And so a key parameter in this model will then be psi, the fraction of time needed to show that you're not armed. So if your output is less than psi times your potential, then you're armed and ready to overthrow the government. If it's not, then you pose no threat to the government. But of course they don't know which you've done. So they'll have to try to infer that from your output. So here's the simplest game. If we're in game 1, then the citizen chooses an output quantity. If she produces more than psi theta naught, which is the productivity in the simple game, then the government simply chooses between punishing the citizen or sharing the output with the citizen. The government punishes the citizen's payoff is minus B, where we can think of B as a very bad thing. Think of it as the death penalty. And psi times Q is the government's share of output of what remains if the government chooses to punish the citizen. The notion here is that psi is less than 1 but more than 0. So it's costly for the government to punish the citizen, but not nearly as costly as it is for the citizen to be punished. The alternative is that the government picks a share of output T to be given to the citizen, and the government keeps everything else. Now, essentially, to break ties in this model, instead of considering this limiting game, I consider a sequence of games in which the citizen is able to retain a fraction delta of the government's share. So the citizen gets to keep delta times Q minus T. Think of these as crumbs that the citizen is able to hold on to at work. Imagine people working in a gold mine who are able to come out of work every day with a few grains of gold dust in their shoes. Not much, but something. And this will turn out to break ties in terms of how much the citizen wants to produce in later parts of the analysis. So the citizen basically gets T plus delta times Q minus T. The government can set a transfer of 0, in which case the citizen gets to consume delta times Q. And we'll look at the behavior in this game as delta goes to 0. So the citizen is getting very small crumbs indeed. So it's really just a way of selecting equilibria in the limiting game where delta is 0. Now, if the citizen produces a smaller level of output, less than psi times theta naught, then the government can still choose to punish the citizen, or it offers her a transfer. But now, because the citizen prepared a rebellion, she has the option of either accepting the transfer that's been offered to her, or rebelling against the government. If she does, the government gets the punishment payoff of minus B, and the citizen gets to keep a fraction lambda of her output, where lambda is bounded away from 0, but not equal to 1. In this setting, obviously, if the government knows that the citizen has prepared a rebellion, and it observes that output is less than psi times theta naught, so it knows the citizen has the option of rebelling, it can try to appease the citizen. If it does that, then the citizen will simply compare her payoff with lambda q. Let's not worry about what happens with delta. The formula becomes just a little bit more complicated. But essentially, the government has to appease her with an offer of lambda times q. If that happens, the citizen will not rebel. The government doesn't want to pay any more. That's dominated. And I then assume that the government's share, if it goes through with this offer, 1 minus lambda times q, is smaller than the share phi of q it could get by punishing. So this makes for a nasty government that prefers to punish rather than to appease. And so not unlike many dictatorships that we see. And so in this situation, the government, seeing that the citizen has produced a low output, will always punish that. The citizen, recognizing this will happen, will not produce a low output because it will get her a payoff of minus B in equilibrium, whereas she can get the payoff of delta times Q if she produces an output quantity in excess of psi times theta naught. What's the best Q that she can produce under those circumstances? Theta naught. She'll just produce out to capacity. And so the equilibrium to this game is very simple. If we're in democracy, nature chooses the productivity parameter, and then the citizen decides whether or not to opt for the high productivity technology or the low productivity technology. In expectation, the expected productivity parameter from the high productivity technology or from the innovative technology is greater than theta naught. So the citizen wants to go ahead and opt for the high productivity technology. But theta lower bar, the bad realization on the new technology, is sufficiently low, the citizen prefers to stick with theta naught. So it was jetpacks, they don't really work well, let's stick with cars. But in expectation, it's better if you take the high risk, high reward technology. The citizen then chooses an output quantity. The government doesn't know what the citizen's productivity was, but then decides to offer a transfer, what transfer to offer to the citizen. If the citizen likes the transfer, she takes it. Otherwise, she expels the government. If she does that, the government's payoff is zero. The retirement package for former elected officials is a lot more attractive than the one for former dictators. And the citizen gets to keep a fraction psi of Q. And what will happen in equilibrium is essentially the government will extract the available surplus, 1 minus psi of Q, to stop the citizen throwing them out and let her keep the rest. Think of psi as either the cost of throwing out an experienced government that might know what it's doing, or as a byproduct of the government stealing all the doorknobs on their way out of the door and hiding the keys to the file cabinets and so forth, and generally doing sort of gremlinish thing that governments do. So let's go back to the more interesting simple case here, in which the government decides to opt for the more complicated technology. So the government opts for the innovative technology, but remains authoritarian. So it imposes this technology on the citizen. The citizen now doesn't have the theta naught option. Nature then picks technology, either it's theta lower bar or theta upper bar. So there's a slight welfare cost to this, because on average, on average is better than theta naught. The theta lower bar is worse than theta naught. So we're not getting that feedback from the citizen. The citizen now chooses an output quantity. The government then, not being able to observe the citizen's type, has to decide whether to punish the citizen, or if not, how much of a transfer to offer the citizen. And the citizen, if she is armed, now decides whether to expel the government, whether to overthrow the government or accept the transfer. Now, under some circumstances, the government can figure out what the citizen's productivity was. So, for example, if the government, whether the citizen is armed, if the government observes that the citizen is not armed, if the government knew for sure that the citizen was unarmed, then the government would prefer to set a transfer of 0 and not to punish the citizen, and just pocket total output. And under those circumstances, the option amongst those that does best for the citizen is the one that has the highest output. So in that situation, it's fairly easy to predict what will happen. The citizen produces at full output, the government confiscates everything. The government can tell that the citizen is safely unarmed when she's producing more than psi times theta upper bar. When she's producing so much that even the high ability type would only be able to produce that output by having worked so hard that she didn't have time to arm. Likewise, if the government ever observes an output less than psi theta lower bar, it knows that regardless of the citizen's type, she's armed. And so then it has to decide whether it prefers to appease or to repress, and we've already seen by assumption that repression is more attractive for the government than appeasement. Finally, the question is, how severe is the monitoring problem? So if theta lower bar is bigger than psi theta upper bar, actually bigger than or equal to, then it's possible for the low type to work hard enough to prove that she's not armed. The thetas are close enough that a low ability type can work enough to prove that she's unarmed. And at that point, it's fairly straightforward to show that all the subgame perfect equilibria that satisfy all the perfect Bayesian equilibria to this game that satisfy the D1 refinement involve both types of citizen working at capacity and the government punishing any output that's below psi theta upper bar. So in this case, we're going to get a fairly efficient use of technology. The only slippage here from the greatest possible output is that the government doesn't know the realization of theta, whereas the citizen in democracy does. So democracy has a slight potential advantage over this because the citizen knows when she's low productivity. It can switch to the backstop technology of theta naught. So when the jetpacks don't work, we switch back to cars, but if it's airplanes, we use the airplanes. And the government can't tell that. So there's a slight efficiency loss. But basically, the threshold for the government to decide to endogenously democratize, to endogenously liberalize, is fairly high in this game. Now, what happens when that condition is violated, when we have a more serious monitoring problem, when theta lower bar is smaller than psi theta upper bar, so that it is impossible for the low quality, low productivity citizen to prove that she's not armed. When the high ability type can always pool with the low productivity type and pretend to be a low productivity type doing her very best. Now we have a more interesting and complicated problem. So once again, we have the polar cases. Any production below psi theta lower bar is punished because obviously the citizen is armed. Anything above psi theta upper bar is not punished because the citizen's obviously not armed, but now, and indeed, if we see a productivity between theta lower bar and psi theta upper bar, by the way, the government knows the citizen's armed because the low productivity type couldn't have gotten there. Only the high productivity type could have, and they're armed, so fine, that's easy. But now, what happens if we're in that interval between psi theta lower bar and theta lower bar? So now, when the government sees that, it can't tell whether it's looking at a citizen who's doing their best or not. It turns out that there's only going to be one output level in this zone, this contested zone, that gets produced. So there's only going to be one output level in this zone of ambiguity in which you can't tell whether the citizen is armed or not that gets produced. Suppose there were two. Well, essentially, the indifference curves for the low type are flat. They're not quite flat if the citizen gets to keep delta, but let's forget about that for the moment. It's still true that they're flatter, and that's all we need. The indifference curves for the citizen are flat in the sense that, let's ask, now, if the citizen's at some equilibrium point, suppose there's a point inside of this interval that gets produced. The first thing we know is that it can't be produced only by the high types. If it was, the government would punish them for sure. They get a payoff of minus b. They could always just exceed psi theta lower, theta upper bar and get a payoff of 0 or delta times q. That's better. So they wouldn't go there. And the low types certainly wouldn't produce that output because they're going to be shot if they do it. Likewise, it couldn't be produced only by low types because then the government wouldn't punish. There's no point. You're throwing away output. You don't punish. The high types will now pool. So those equilibrium break. You can only get points inside of this interval in which both sides are mixing. But they can't be mixing at 2 points. Why not? For the low types, the probability of being punished that's needed to deter you by moving away from a given point is flat. If you're being punished with some probability p, some probability pi for producing an output level q naught, if you move to q1, you're still going to be expropriated because you aren't able to rebel, and the government will never offer you anything in this zone, as it turns out, if they don't punish you. Then, if you move to that point, the government will simply punish you with the same with the same payoff of minus b that you were getting originally. And so you're indifferent amongst any point that offers you the same probability. You'll immediately jump to anything that offers you a lower punishment probability, and you'll eschew any point that gives you a higher punishment probability. For the high types, however, if they aren't punished, they get to rebel. And if they rebel, they keep lambda times their output. So if they deviate upwards, then rebellion is actually more deep. The same probability becomes more attractive. If you're being punished with probability a half at an output level of a half, and you go up to 0.6, and you're still being punished with probability of a half, well, you get to keep more of your output, so your lotteries just become more favorable. So you're willing to move. The others aren't. Likewise, if you move leftward, you're less willing to move. So it takes more of a probability to deter the high types or to keep them indifferent between their initial position and this new offer. So it can't be the case that there are 2 points at which both types are mixing, because the probability that would induce the low types to mix would cause for the high types to always pick the higher output of the pair. The one that would induce the high types to mix would always leave the low types out of the mix. They would always eschew the higher output level because it was associated with a higher punishment payoff, a higher punishment with no higher payoff. And so we're only going to get one of these points at maximum. It's then fairly straightforward to show that at this point, the low types are all producing that output level. At least they're being punished probabilistically instead of certainly if they produce below psi theta lower bar. And they can't produce any higher quantity because they're not productive enough. The high types then mix between this probability and their maximum output. At least they do if they're not exotic. If the probability phi of being a high type is sufficiently small, then the government will simply say, well, they're so rare. Unless this person is Superman, they can't possibly take us on, so we'll just treat everybody as if they're a low type and run a tiny risk of being overthrown and confiscate all of the output and not punish anybody. But unless we have a really, really low probability of high types, which makes the game uninteresting, if high types are non-trivially rare, then essentially they're mixing between their maximum output and this mixed point in this contested region, and the low types are all producing at that one mixed point. Now that leaves us with a continuum of equilibria. Anywhere inside the contested region, we could get some Q that satisfies our conditions for a perfect Bayesian equilibrium. Just assume that you get punished horribly if you move away from it. But is that credible? So let's apply the D1 refinement. And now we can stick with our same diagram. Let's think about some candidate equilibrium point and the set of probabilities that would deter an upward deviation. Suppose that you're supposed to produce a quantity of a half, and you jump up to a quantity of 0.8. Well, the probability needed to deter the high types from 0.8 is much higher than the probability needed to deter the low types. And so the low type probability, the action by the government, the prospective action by the government that induces deviation for the low types is a proper subset of the actions that induce the deviation by the high types. Therefore, under the D1 refinement, the government should interpret these upwards deviations as coming from the high types and punish them. The government now, in this off-equilibrium world, sees the deviation, consults its game theory textbook, and says, aha, this must have come, according to the D1 refinement, from a high type. The high types will rebel against for sure, and the high types will for sure overthrow me. I'm going to punish this person, because it's much cheaper than appeasing them. And so that deviation is unattractive even for the high type, certainly for the low type, being punished for sure. Now suppose we deviated leftwards. Now the inequalities are reversed, and the D1 refinement has us attribute the deviation to the low types rather than the high types. And the government doesn't punish, which breaks the equilibrium. Both types now under defect to this lower output level. So no point on the interior of this contested zone can possibly be an equilibrium, a perfect Bayesian equilibrium that survives D1. The one point that does survive is at the left edge. If we're on the left edge of the contested zone, if we're at psi theta lower bar, we've produced just enough so that the low types show that if they're low types, they're unarmed. Well, now there's no leftward deviation. If you deviate leftward, you're out of the dangers of this contested zone, and the government has a dominant strategy of punishing you. If you deviate rightward, then the D1 refinement tells us that the government should think you're a high type and they punish you. And so that equilibrium survives. And so in this setup, the one surviving equilibrium has the government and the opposition mixing between psi theta lower bar and theta upper bar, the citizen mixing, when she's at high productivity, producing psi theta lower bar when she's at low productivity. Output is lower and worse for the government in both cases than it was in the under the hypothesized case in which monitoring problems were less severe. So as theta lower bar and theta upper bar moved apart, the equilibrium in authoritarian rule became much less favorable for the government. There's a key threshold above which the government will repress and below which it doesn't. The threshold on what the citizen gets to keep if she votes the government out of office in democracy. Think about these as the post-transition guarantees, if you will. And what we can show here is that the government will choose to repress when the democratic guarantee, the democratic share that the citizen gets to keep in democracy is above a certain threshold. There's a threshold when the monitoring problem is easy, and there's a different threshold when the monitoring problem is hard. Essentially, the government is getting out of. The government gets a fairly attractive payoff if the monitoring problem is easy to solve. It demands the citizen produce at full capacity. She does. It keeps the difference. The citizen isn't always using the right technology, but otherwise it's very efficient from the government's point of view. If the government is facing the harder monitoring problem, it faces the probability of endogenous transition. It might actually be overthrown. And if it's not, we get inefficient output. The higher types aren't always producing theta upper bar. Sometimes they're mixing with the low types, giving us a lower output. And the point at which they're mixing is no longer the maximum output of the low types, it's psi theta lower bar. they're producing an inefficiently low quantity, high types and low types together when they mimic the low types. And so, in this case, the government is willing to put up with democracy even if it gives the citizens better guarantees. One can actually characterize what these thresholds are, and it's fairly easy to show that the amount of democratic guarantees the government is willing to tolerate and still liberalize is greater when it's facing the harder to monitor technology. So what does all of this tell us? What it tells us is that authoritarian governments that are facing harder to monitor, harder to understand technologies will simultaneously be more likely to be overthrown if they adopt the new technology and try to monitor it and try to live with it. They accept an equilibrium probability of being overthrown. And they're also more likely to give up on being authoritarians and transit to democracy. So, what do the data say? Well, it's unfortunately not something that's in the NEPA accounts. Namely, we can't find monitoring problems as a fraction of output or informational rents as a fraction of output broken out on the national income and products accounts. I think it's too bad. It would be great if people would at least make an effort at adding that to our panoply of statistics. But we certainly see that there's a lot of anecdotal evidence, at least, to suggest that democracy happens more often when we have more modern economies and harder to monitor technologies. Leonard once talked about the importance of the government being in control, the communist government being in control of the commanding heights of the economy. His idea of the commanding heights is maybe not what ours would be. In particular, communications, broadcasting, and publishing are really important to a regime's ability to stay in power. We know that, for example, in 1962, when the French army in Algeria rebelled, taxi drivers basically tried to undermine the ability of the Air Force to ferry troops to France by blocking runways and generally trying to gum up the fairly fragile technology of air transport to keep the army in check. When the government of Hugo Chavez nationalized petroleum, people in the petroleum industry resisted, and the technology started to fall apart. We know that, in particular, there are panoplies of there's a panoply of anecdata, but in particular, during the antebellum period in the United States, there were strict laws against teaching slaves to read. Doesn't make sense in terms of productivity. A literate slave would be more productive, but a literate slave is also more likely to escape and more likely to organize other slaves to escape, both because she'll encounter the ideas of freedom and because literacy will make her a more effective rebel. And so you see you in fact saw slave owners abandoning that level of control. I think slavery fits very easily into this model of authoritarian rule. Dew talks about slaves and guns. In particular, once the Civil War had broken out and getting yourself liberated amounted to showing up at the nearest U.S. Army post that happened to be in the area, slave owners took a much dimmer view of sending slaves out to hunt for game. Again, essentially choosing the theta-naught technology, choosing not to use the harder to monitor technology. Now, there's a tendency to find something called a resource curse. We find that poor countries and primary resource exporting countries are more likely to be authoritarian. We might imagine that the low productivity technology, the theta-naught technology, is more likely to leave us at a low output level. That's consistent with this model and consistent with our finding that those poorer countries tend to be more authoritarian. There's a controversy now. Haber and Rinaldo claim the resource curse isn't really there, but there's also lots of evidence from Ramsey and Ross and others to suggest that there is a resource curse. I actually find Ramsey's evidence most persuasive, and if people want to talk about that in Q&A, I'm happy to go on about it. But in any event, the resource curse claims that primary resource exports are somehow magically beneficial for authoritarian rule, that they magically help to cultivate authoritarian rule. But there's no causal mechanism that's well specified. This analysis suggests such a mechanism if it's easier to monitor the extraction and production of primary resources than it is to monitor manufacturing and other higher value added activities, then we would get something that would look very much like the resource curse caused by information rents rather than by something magical about goods that come out of the ground. Finally, there's a fair amount written about the internet to suggest that democracies are more wired, more connected with the internet than are authoritarian countries with authoritarian regimes. I'd encourage you to look through my discussion about Kedzie, who argued that in fact the internet promotes democracy. I've reanalyzed his data and found that and shown that his finding about democracy not causing the internet is a fragile conclusion. Finally, I want to, and Helen Milner has also done some interesting analysis of the internet and democracy and finds that democracies are more wired. Again, the causal arrow is in question. So, finally, I add a little bit of additional evidence, turning to Granger causality. So, we have short time series, about 15 years long, on internet connection for most of the world. The Internet Services Consortium keeps a big database on this. Now, in 1980, there were only 267 internet nodes in the world. So the internet has really come from a cold start to a huge level of penetration everywhere. But we can use the familiar Granger causality analysis, tool of Granger causality analysis, to get some idea of the nature of the feedbacks between the systems. We all know that there are considerable problems with Granger causality. Famously, tapping on the brake pedal seems to Granger cause accidents. So why do we keep brake pedals in cars? But for all of the flaws in Granger causality, we can find similar examples about correlation and regression analysis and other inferential tools. And I don't think that the potential shortcomings of Granger causality should stop us from using this sort of analysis if it can possibly shed some additional light on what we're looking at. Just to review, the notion here is that we'll take some variable, let's say it's internet connectivity, and regress that variable on its own lags. We then add lags of something else, let's say democracy, to the equation, and do a test. Does the addition of the lagged levels of the history of democracy help us to improve our forecast of internet connectivity, controlling for the history of internet connectivity? If it does, then democracy is said to Granger-cause internet connectivity. I think Granger made the mistake of overselling his method. If he just called it Granger's association method, we'd all be perfectly happy. So what we're really looking at here is whether democracy is Granger associated with the internet. And we have some additional interesting technical problems caused by the fact that we have a wide panel of short time series. We know that short sample bias is a key problem when we're analyzing this sort of data. Holtzik and Nui and Rosen found a way to deal with that by using lag values of the explanators to instrument for the various components of the model to try to purge basically the correlation between the residual term and the more recent lags after you first difference your model and proceed with the analysis. So in this setup, let's just go ahead and apply their method. I'm using Windmeyer's bias correction for the standard errors. We know that standard errors with this methodology tend to be biased downward, and you obviously don't want to encounter that. Essentially what you find is that polity 2 does Granger cause internet connectivity. Internet connectivity does not Granger cause polity 2, which is a widely used measure for democracy. Somewhat more surprisingly, real GDP per capita doesn't Granger cause internet connectivity, which surprised me somewhat, but there it is. Those are the data, that's the evidence. And so this, if people want to ask me more about this analysis, I'm happy to go into it. But essentially, this analysis is consistent with the notion that, in fact, democracy drives internet connectivity as would be predicted by the model that we've been looking at, and not the other way around.